This is part 3 of 3 finding zeros of polynomials. We're going to start with a warm-up of some long division, just to review that. This time we're going to be dividing by a quadratic, which typically we are dividing by linear functions, so it'll be a little different, but the process is still the same. When I'm writing my value inside here, I notice that I don't have a cubic term, so I'm going to put a placeholder in of a 0. Sometimes there's more than one term that's missing. This time it looks like it's just the cubic term. And then I'm going to start that 4-step process: divide, multiply, subtract, bring down. So I'm going to take 4x to the 4th divided by x squared. Remember, you can always stack them to figure out what that is going to simplify to. So we would subtract these exponents and we get 4x squared, and then we multiply. 4x squared times x squared is 4x to the 4th. 4x squared times 2 is 8x squared. So we're going to subtract and we get just an x squared, and then we're going to bring down. And we'll start that process over again. How many times does x squared go into x squared? Well, that's just 1. 1 times all that, we get x squared plus 2. Now 2 is not the same kind of term as an x, so I'm going to put that over here and bring down this -1 as well so that they match up. Okay, then I'm going to subtract, so I get -x minus 3. And when I go to divide, you can't divide something bigger into something smaller, so this is just our remainder right here. And remember, you put the remainder over what you were dividing by, so you always put a plus sign. And then my numerator would be -x minus 3, and my denominator would be x squared plus 2. So this whole thing is my answer. All right, so now we're going to continue on with what we've been doing in 3.3, listing the possible rational zeros, using synthetic division to find the zeros. We've done all that before. The new part today is then use those to write the function in factored form. So everything that we did in part 2 plus a little smidgen more. So we're going to start by finding our p's and q's. P this time is -1. So we have plus or minus. Oh, I probably should have written down the -1 first. So we know what we're finding factors of, even though there's not a lot of factors of -1. There we go. Plus or minus 1. Okay, and then we need our leading coefficient. That's our q value. So we need factors of 4. 1, 2, 4. And then we take our p divided by q. So we have plus or minus 1 divided by 1, which is 1, 1 divided by 2, which is 1/2, and 1 divided by 4. Now it is really important that you remember the constant goes on top and the leading coefficient on the bottom, because if you divided these the opposite way, you would get different possibilities. There's 3 positive possibilities and 3 negative possibilities, so altogether we have 6 possible rational zeros. And then remember, you can use a graphing calculator or Desmos graphing software. The link for that is in Schoology. To narrow down which of those 6 you want to use. If you don't have one of those, or you want to just try them out, you can start with 1, see if it works, then do -1, 1/2, -1/2, 1/4, -1/4. If we do start with 1, we put these leading coefficients, or all of the coefficients really, across the top. 9, -1, -1. And then we go through that process of multiplying and adding. Hoping that we get a 0 at the end. And we do. Remember, 0 means it is a factor, so that's a good thing. Now, hopefully using your calculator or your Desmos, you also can see that negative 1/4 is another 0 from our list up here. Remember, we don't go back and use the original coefficients, you use these coefficients that are given to you. So I'm going to drop the 4 down and then multiply the negative 1/4. Then I'm going to add, then multiply, then add, then multiply, and we do in fact get another 0. All right, so we started with a quartic. We divided once to get a cubic, divided again. This is a quadratic. 4x squared minus 8x plus 4. And then we're going to factor it to find our 2 remaining zeros. It has a GCF that we'll take out first. So everything is divisible by 4. And then x squared minus 2x plus 1 factors to x minus 1, x minus 1, which tells us that our 2 remaining zeros are 1 and 1, which we also had a 1 at the beginning. So if we go back and kind of look at all the zeros we found, we have 1 showed up 3 different times, and then we also have a negative 1/4. So that's kind of where we stopped last time, but now we need to do this last sentence. Use them to write the function in factored form. So we want to write 1 as a factor. So here we're going to have f of x equals x minus 1. It happened 3 times, so we would say cubed. And then we would say x plus 1/4. Now that's not going to be our final answer because you can't have fractions in a factor. All right, so how do we fix that? Well, to get rid of that fraction, we would need to multiply by 4, the denominator here. So if we multiplied this by 4, we would have x minus 1 cubed times 4x plus 1. So we multiplied everything in here by 4. So 4x, and then 1/4 times 4 is 1. And you might be wondering, well, how can you just do that? Well, let's take a look at what we had before. Do you see how down here we took out a 4? So all we were really doing was putting back in that 4 that we factored out down here. So we really did keep it the same. You just want to make sure that there's no fractions in your final answer. Alrighty, let's try another one. Same directions as the first. Start by listing off your possible zeros, then use synthetic division, and then we're going to end up putting a factored form at the end. So please pause and see how far you can get on your own, and then come back and check. All right, so our p-value this time is negative 36. This is going to have a lot of factors. Let's see, 1, 2, 3, 4, 5 doesn't go in, but 6, 9, 12, 18, and 36. Luckily, our leading coefficient is just 1, so it only has factors of 1, which means that all of these, when we divide it by 1, stay the same. So our P over Q list is the same thing as our P list. So if we count those up, we find out that we have 18 possible rational zeros. So I would put that equation into Desmos and see which ones I should start with. And I find that 3 looked like a good one. So 1, 3, negative 5, negative 27, negative 36. And I'm going to drop down the 1 and go through my multiplying and adding. Hopefully you've already done all of this and you're just checking along with me to see if you had it right. I really want you to pause a lot and work for yourself. That one worked. Okay, now I'm going to look at Desmos to see if I can find another one. And it looks like possibly negative 3 might work. So I'm going to check it using synthetic division. You do always have to do the synthetic division part. You can't just look at it and use those. So make sure you're always doing this portion of it. And that one worked too. Yay! So we have a quartic. We divided it once to a cubic, divided it again to a quadratic. X squared plus 3x plus 4. And I want to try to factor that. What multiplies to get 4 and adds to get 3? Nothing. So it doesn't factor, which means I then have to use the quadratic formula. So opposite of b plus or minus b squared minus 4ac all over 2a. And we end up with negative 3 plus or minus the square root of negative 7. So here we're going to have an imaginary number. So negative 3 plus or minus I radical 7 over 2. Okay, so let's see where we are. At this point, we have found 4 zeros, which is how many we need. We have 3, we have negative 3, and then we have negative 3 plus or minus I radical 7 over 2. That's the 4 zeros we were looking for. But if you remember, the directions want it in factored form. So we have to take those zeros and put them in factored form. That's supposed to say form. So the 3 and the negative 3, not a problem. We have f of x equals x plus 3, x minus 3. Now, some of you are looking at this ugly number going, how in the world do you put that in factored form? Well, you really don't. When it's gross like this, you go all the way back to when it was nice, which is this x squared plus 3x plus 4. So if it doesn't factor, you go back to where you had your quadratic, and that's what goes in your factored form. So this is our final answer.